Thanks very much, Ron, for the introduction. Hello, everyone. My name is Meta Tamel. I am a developer advocate at Google. I'm actually based in London, so right now it's evening time in London, but I'm very happy to speak to you, most of you, I guess, in the US. Yes, so today I want to talk to you about event-driven serverless containers architectures with Knative and Cloud Run. Everything I talk about today, it's already on speaker deck. So if you want to get the slides, feel free to check out my speaker deck. And I like to do demo-driven talks. So there will be demos as we go along, and all the demos they're already on GitHub, on my GitHub Knative tutorial. I will share the link for that as well. So everything that you might want is already out there. All right. So as Ron mentioned, we had a couple of buzzwords, serverless and containers, in this talk. They are buzzwords in some ways, but at the same time, they're real things, right? Like we actually use them to build software. But then we had to make this unfortunate choice when it comes to software development up until recently. Normally when you start a project, nowadays, you want to use serverless, and the reason why you want to use serverless is that serverless gives you all these things for almost for free. For example, it gives you free management, so you don't have to manage machines. It gives you the base level security, so you don't have to worry about securing your VM or blocking ports, stuff like that. It gives you pay for use, so you only pay for what you actually use, and it gives you these event-driven kind of functions where you just write your function, your business logic, and the infrastructure around your function is kind of managed for you by the cloud provider. So serverless is great, and that's why people want to use it, because it gives you all these things, all these foundations that you can build things on top of. And it gives you the velocity, right? So you don't have to worry about the details of the infrastructure. You can just focus on the business logic that you want to write. Now, serverless is great if you can use it, but there are certain times where you cannot use serverless. For example, maybe you want to use a certain language, and that language is not supported in the serverless platform that you're trying to use. Or maybe there's like a limitation, like timeout or some other limitation that comes with the serverless framework. So what happens in those cases is that people usually fall back to containers. And containers, as most of you probably know, it's a way to package your application and its dependencies and its environment into a context. And this context, what we call a container, the unique thing about this context is that, first of all, you define this context yourself, right? You define what goes into that context in terms of the libraries and dependencies and the ports and everything. And then you can also rely on the fact that this context that you created, it runs exactly the same way on your machine or in the cloud, right? So containers gives you this flexibility because you pretty much define what you want to run, but at the same time, you kind of lose the benefits of serverless, right? You don't get auto scaling. You don't get the elasticity that comes with serverless. You don't get this managed security. So all of a sudden, all of these things that you take granted on serverless becomes your problem, right? So this was an unfortunate choice that you had to make at the beginning of your project when you're deciding on how to implement your your solution. But thankfully, there are projects now like Knative and Cloud Run that tries to bring serverless and containers together. So Knative, it's an open source project. It was started by Google, but now a number of companies like Red Hat, IBM, VMware, and others, they're contributing. It runs on Kubernetes, so it runs on anywhere you have Kubernetes. So it can run on-prem, it can run on Google Cloud, it can run on AWS. So anywhere you can run Kubernetes, you can basically have Knative on top and install Knative on top and then run it as well. Then there's also the managed versions of Knative on Google Cloud. So there's something called Cloud Run, which you can think of as the managed version of Knative on Google Cloud. And then there's another version called Cloud Run on Anthos, which is the version of Knative that gets installed on top of Google Kubernetes engine. So it's for those people who want to stay in Kubernetes ecosystem, but they also want to get the benefits of Knative. For that, we have Cloud Run on Anthos. So you have a spectrum of choice when it comes to Knative. You can run it the open source version on wherever you want, or if you're on Google Cloud, you can pick and choose if you want to go with the managed version that doesn't run on Kubernetes, it runs on Google's infrastructure, or Cloud Run on Anthos that runs on Kubernetes itself. Now the Knative stack looks like this. So at the bottom layer, we have Kubernetes as a platform. On top of that, you need to install a gateway because Knative, it doesn't try to figure out how to get traffic to your containers. It relies on a gateway that you install. Typically, the gateway is Istio, because Istio is one of the most featureful gateway that works with Kubernetes, but there are other choices as well. Once you have your gateway installed, you install the Knative components. There's two separate parts of Knative Serving and Knative Eventing, and I'm going to talk about these both. So the main focus of this talk is more about eventing. But to understand eventing, we have to look at serving a little bit. So in the first 10 minutes or so, I want to look at serving, and then I'm going to switch to eventing and then show you an eventing, the eventing features of Knative, and also get into a demo that I want to show you with Knative Eventing. So that's Knative, and as I mentioned, you can run it anywhere you want, but then there are products that are being built on top of Knative, like Cloud Run or Cloud Run on Anthos, and there are other products from other cloud providers as well. So if you're running in a cloud, you might want to check out what Knative implementation there is, and maybe use that, because it will be easier when we're using Knative instead of using Knative directly. But in today's talk, I'm using Knative open source because I think, by just showing that, it's more relevant to more people. That's why I will do that. But everything I show in Knative, it also applies to Cloud Run as well. So if you want to try it on Google Cloud, you can just go with the Cloud Run version. All right, so let's first talk about Knative Serving, and then we'll get into Knative Eventing. Knative Serving, it's all about deploying containers in a serverless way. So what I mean by that is that in Knative Serving, you create what's called a Knative service, and then in this Knative service, you define where your container lives. So you specify where your container image is, and then you define a configuration for your service, like the environment variables and other things. And then you tell Knative, take this container and deploy it for me. And then Knative figures out the rest for you. So what Knative does is that it takes your container, it creates a pod, then it configures traffic to that pod. So under the covers, it basically creates the Kubernetes pods and deployments, and it sets up Istio, if you're using Istio, with the gateway and virtual service and all that kind of stuff. And then your pod will be running, and people will get to your pod, so the traffic is also, the public traffic is already set up as well. Then Knative sets up automatic scaling, so by default, your container will run on a single pod, but it will scale up and down as people use it more or less. And then on top of that, you get configuration and revision management. So every time you deploy a new version of your container, you get a new revision. And once you have multiple revisions, you can split traffic between them. So these are the things that Knative Serving does for you. So it basically allows you to deploy a container, get the traffic to it, get it auto-scaled, and get traffic to that container configured as well. As if it's like a serverless function, basically. So it kind of tries to give you that environment that you expect from a serverless function, but for a container. Now, the Knative Serving has 4 main constructs that you need to know. First is the Knative service at top layer. Then we have the configuration for the service that points to the pod, to the image and other configuration that your service might have. Then you deploy the service and configuration together. Then you get a revision. And this revision will be pointed from a route. So by default, this revision will get all the traffic through this route. And then every time you make a change to this configuration and deploy again, you will get a new revision, and the route will be pointed to that revision, right? So these are the main parts of Knative Serving: the service, configuration, revision, and the route. And actually, let me just show you how this works. First of all, I have this Kubernetes cluster that I already created. So Knative 16 is the one that I had before, but just today I deployed the latest version of Knative, which is 0.18. And I installed Istio, and I installed Knative Serving, and I installed Knative Eventing. So everything is already installed. But we can double check that everything is installed. So if I go to my console and just say kubectl get pods, and just look at the Knative Serving namespace, I should see this Knative Serving pods up and running. Knative is just another application running on top of Kubernetes. So those are running. And then if I do Knative Eventing, I should see the Knative Eventing pods running as well. Now, if I want to deploy a service to Knative, what I need to do is, first of all, I need to create a service.yaml. Well, before that, I should also point out, in this first service, I want to deploy a Hello World service, and I have the code here in C# or Python. If you look at the C# one quickly, what this service does is that when it receives a GET request to our service, it will look at an environment variable called target, and then it will just say hello target, whatever that value is, right? So it's something very simple, but I just want to show you how this works in a simple way. So I created a Docker file for this, and this is the Docker file for my .NET app that I pushed to Docker Hub. And now I want to create a Knative service. So to create a Knative service, I create a YAML file. Now the kind of the service is that it's a service, so it's a Knative service, and I'm using the Knative API. I'm calling the service Hello World, and I'm deploying into default namespace. And this is my image that I pushed already, Hello World version 1. And this is my environment variable target version 1 that I'm passing in as well, right? So this is how you define a service in Knative. And to deploy this, we will come back here. But then before I deploy it, let me actually watch something. So here I'm watching Kubernetes pods, Knative service, configuration, revision, and route, all the things that I talked to you about. So let's watch those. Right now, there's nothing yet. But to deploy the first service, we'll just say service v1. And now we're deploying the first service. You will see that immediately Knative will realize that there's a change. It will create a Hello World service. It created a configuration for the service. It created the first revision. So this is generation 1, the first revision. It created a route that points to that service. And Knative it comes with this dummy zip.io domain that you can use for testing. So that's what I'm using here. It also created the pod for me. So all the things that you normally have to create yourself, Knative creates it for you. And then if I do a curl and hit that URL, it says hello v1, right? So our first service is up and running. Now, if I want to do a change to my service, so let's imagine in the service 2, I want to change this environment variable from version 1 to version 2. I can come here and do that. So that's a configuration change. And then in version 3, I am changing my Docker image. So I'm changing my image from version 1 to version 3. And in this version 3 on my image, I am changing my message from hello to bye, right? So I'm in version 2, I'm doing a configuration change. In version 3, I am doing a code change, right? So let's do these changes and see what happens with Knative. So first, let's apply the service v2. Now we are doing the configuration change. And you'll see that Knative immediately recognized that this is a new revision. So it created the new revision. It created the pod for this new revision, and it updated the route to point to that revision. Now, if we do a curl again to the same URL, it says hello v2, right? The service is updated. That's all it takes to update a service in Knative. Now, if I want to do a code change, I will just change the Docker image and apply that. And now Knative again creates the version 3 revision, and then it's creating the pod for the new code. And then you'll also realize that it's scaling down the first pod, the version 1. The version 1 pod is being scaled down to 0 because we haven't used it for 60 seconds, so it's scaling down. So there's auto scaling as well. Now, if you do a curl again, now our message is by v3, right? So this is how you can do a code change. But of course, this is not how you would change code in the real world. What you need to do is you need to create a new version, deploy it, test it out, and make sure that it works before sending traffic to it. Knative makes this really easy, actually. So for example, in this version, I'm going back to version 1 on my service, but then I am naming my revision. Now remember, in our revisions, we have random names, right? These are the revision names that are random, but I can actually name them. So here I'm naming this to version 1, and I'm also setting a traffic rule. And here I'm saying this version 1 revision will get all the traffic, but if there's another version that I am deploying, it won't get any traffic. That's what I'm doing here. So let's deploy this and see what happens. So service v1 pinned. So now we are going back to service 1, but the difference is that the revision name is hello world-v1. So I have a predictable name. And if I do curl again, I'm back to version 1. Now let's deploy the version 4. In version 4, again, I'm giving my revision a name, hello world-version 4. But then in the traffic rules, I'm still sending all the traffic to version 1, right? So I'm deploying version 4, but I'm not sending traffic to it yet, right? I'm doing a silent deploy here. So let's go back to here and do kubectl apply service v4. Now this deploys the version 4 or our service. You can see that the pod is created as well. Now if we do a curl again, we are still at version 1. So we did a silent deploy of version 4, and we can actually get to version 4 by going to our URL and just adding latest dash at the beginning. If we do that, we can get to version 4. We can test it out, and if we are happy with it, we can start sending traffic to it. But the main URL still goes to version 1. So that's how you can do silent deploys in Knative. And at some point, if I want to send traffic to version 4, I will go to my traffic rules, and I will just say, okay, for this service, I am sending half of the traffic, 50% to version 1, and the other 50% to version 4, and then everything else, like version 5, won't get any traffic still. So if you want to do that, let's do it. Service v1, v4 split. And now you will see that there's no new revisions because we haven't created anything new, but we just updated the route to do traffic splitting. And if we do a curl again to the main URL, you see that it says version 4. If you do another curl, it says version 1. So we are doing roughly 50% traffic splitting, right? So this is Knative Serving, and if we are done with our service, we can simply say delete Knative service, hello world, and this will delete the service and remove everything, and we will be back to 0 without any pods. So hopefully this convinces you that Knative Serving is very useful to deploy containers. But I want to talk about Knative Eventing because I think Knative Eventing is even more interesting. So what is Knative Eventing? Knative Eventing, it basically provides you all the building blocks to get events into your Knative services, right? And these events, what we call event sources, they can be in-cluster event sources. So you can have actual event sources within your cluster, but you can also have event sources that reads external events and pulls them into your cluster, right? And once you have these events in your cluster, then Knative also gives you different delivery methods, different ways of getting those events to your event consumers. So in a nutshell, this is what Knative Eventing is. There's, again, terminology that comes with Knative Eventing, like CloudEvents, event sources, brokers, and triggers, and services. So I just want to go through those quickly, and then I want to show you somewhat of a real-world demo that will bring it all together, hopefully. So first of all, the format of events in Knative is CloudEvents. CloudEvent, it's an open source CNCF eventing format. And in CloudEvents, you basically have some metadata about events, like the type of the event, the source of the event, the time of the event, things like that. And then the data field of the cloud event has the actual payload. So for example, in this case, Knative is pulling different events into the cluster, like FTP, GitHub, or Google Cloud Storage events, and then they get into Knative as through the event source, and then they get converted into this common format called Cloud Event, and then from then on, it gets to the broker as Cloud Event. So the broker only sees the Cloud Event, and then the data field will have the actual payload that you're interested in. This is useful because Cloud Event is an industry standard, and also, it's a common format that you can rely on in your services. Now, what kind of event sources we have? So what kind of events you can read into your cluster? Now, as I mentioned, you can actually have pods in your cluster that creates the cloud events themselves and sends those cloud events to the broker themselves. So you can have in-cluster event producers, but you can also have these event sources that you can install into your cluster that will pull events into your cluster. This is not the full list. The full list is here, but you can listen things like AWS events. You can listen Google Cloud Pops-up messages. You can listen Google Cloud Storage events, stuff like that. So there's a lot of different event sources from different vendors that you can install and read different kinds of events into your cluster. Now, once you read the events get into the event source reads the events, and then it passes into broker. Broker is the entry point of the events in the namespace. So whatever namespace you have in Kubernetes that you want to receive events for, you will inject a broker into that namespace. The way to inject the broker is you label the namespace with this Knative namespace injected label. So once you have this label in the namespace, Knative will inject the broker there. In this case, the default namespace will get the broker, and the broker also has a URL, and this URL can be used by internal producers to produce events as well, right? So the broker will get the events, then broker will send those events to the Knative services, but it needs to figure out like how to do that, how where to send what kind of events, and that happens through triggers. So you create a trigger, and in this trigger you filter messages. For example, in this case, we are creating a trigger and we are filtering on Google Cloud Storage events, right? So the type of the events, so the type of the cloud event is Google Cloud Storage events, and then we are passing to a subscriber, which is a Knative service called filter, right? So that's how you connect the broker to different services with different kinds of events. And the services can be either Knative services, but they can also be Kubernetes services. For example, in this case, the API version is pointing to Knative API. So this service is a Knative service that will receive the messages. But if you have pure Kubernetes services, not Knative services, you can also just use the Kubernetes API, and that way Knative will route those messages to Kubernetes service as well. So you can choose what kind of service you want. And then finally, there's something called channels. So by default, the broker uses in-memory channel, meaning all the messages are in memory. This works for demos, but in real world, when you want to deploy a real application, you probably want something more persistent. There's different kinds of channels like Kafka channels, Google Cloud Pops-up channels. So you will probably create those channels and then set those channels as default channels for the broker, and then the broker will use those channels under the covers, right? So you would typically do this at the beginning. You will choose the type of channel you want, and then set the broker, and then from then on, broker will use that kind of channels. All right, so these are the main kind of building blocks for Knative Eventing. Now I want to talk about the different ways of getting events to your services, and then I want to show you the demo, and then we will wrap up at that point. So there's a few different delivery methods in Knative. I call them simple way, the complex way, and the broker and trigger way. The broker and trigger is the one that you should care about for the most part, because it's the most fully fledged and easiest way of using Knative Eventing, in my opinion. But I will mention the other ones as well, just in case, because they're useful in certain use cases as well. Now, simple delivery, it's the easiest way of getting events from source to service. So what you do is you basically just connect the source, the event source, to the Knative service directly with nothing in the middle. This is very simple because it's just one-to-one. But at the same time, it's very limited because you can only do one-to-one. So you can do one source, one service. So there's no fan out. And there's also no persistence here, right? There's no channel in the middle. What that means is that if the source goes down, if the service goes down, then your messages will be lost. For certain use cases, this might be useful. Now, there's another one called what I call complex delivery. In here, you can do fan outs. So what you do is you connect source to a channel, and this channel can be an in-memory channel or Kafka channel or something else. Then from the channel, you create subscriptions, and then you connect those subscriptions to the services. So what this allows you to basically fan out. So you can send one message and it gets fanned out to multiple services. Then there's this notion of event replies in Knative. For example, in this case, we are doing a fan out from channel to a couple of services. And then service 2, when it receives that message, it replies back with that message. And when it replies back, we can connect that reply from subscription to another channel, and we can get that channel, create another subscription, and go to another service, right? So in this case, we are kind of doing something more complicated. This is useful, but as you can see, it's already getting more complicated because we have 3 services that we are connecting, but then we had to create 2 channels and we had to create 3 subscriptions for them. So it gets a little bit hard to manage over time. That's why there's broker and trigger delivery. In this model, what you do is you connect the source to a broker, and the broker is the thing that receives the messages in the namespace. So it's the thing that's injected in the namespace. And then you just create triggers with filters and then get messages from broker to services, right? So in this case, service 1 and service 2 filters on this kind of messages, and then service 3 filters this kind of messages. And then each service can also reply back to received messages. So in this case, service 2 is replying back with red messages, and service 3 will receive that message because we have the filters in place. So as you can see, this use case and this use case, it's exactly the same way. It's doing exactly the same thing, but broker and trigger delivery is much easier because you basically have broker injected into your namespace, so you don't have to worry about it, and then you just need to create the triggers and set it up that way. So that's why I think it's the easier way to deal with Knative Eventing. And lastly, I want to talk about some Google Cloud event sources. So there is this Knative GCP project. It's a separate project from Knative that basically gives you these event sources that you can install into your Knative cluster. And these event sources, they enable you to read events from Google Cloud. So for example, if you want to read PubSub messages, you can install the first one. If you want to read storage events, you can install Cloud Storage Source. So this enables you to read different kinds of events from Google Cloud into your Knative cluster and work with them. All right, so that's all I want to say about Knative Eventing. Now I want to bring it all together with this demo that I built over the lockdown here in London. And this app, what it tries to do is, first of all, this was back in March and April when there were lots of COVID-19 cases in London, and I was trying to, every day at 4 or 5 p.m. they would publish the numbers for the COVID cases for the day. And what I would do is that I would go to the website, I would look at the numbers, I would kind of compare it with the last week, and I would kind of try to see the chart, see how the cases were increasing. And after doing this for like a week or 2, I realized that this is a perfect job for Knative Eventing, because what I'm doing is basically something that can be automated with eventing. So I built this pipeline, and in this pipeline, actually, let me just show you this in my Knative tutorial. So if you go to, I will share this link for my tutorial. but in my tutorial, I give more information about this pipeline. So let me just show you that. So what I do here is that I set up a cloud scheduler, which is a kind of like a cron job, but it runs in the cloud. And with this cloud scheduler, every day at 4 p.m., this cloud scheduler pings a service called Query Runner, right? Query Runner, it's a Knative service, and it runs a query against BigQuery. So BigQuery, it's a data warehousing solution from Google. And the great thing about BigQuery is that it also has a lot of public data sets, right? So it has public data sets for GitHub, Stack Overflow, Reddit, things like that. But it also has a public data set for COVID cases. So what Query Runner does is that it goes to BigQuery and it asks for COVID cases for the given country, and then it receives the data, and then it saves it into a temporary table that you can save on BigQuery. So it queries BigQuery, gets the data, and it saves into this temporary table. Then Query Runner sends a message back to the broker, a custom cloud event with this type, and this custom event goes to another service called Chart Creator. Chart Creator, it's a Python service that will receive this message, and it will say, okay, there's new data, let me get the data. So it will look at this table that was created, it will read the data, and it uses Python's matplotlib to create a chart for this data. And then it saves this chart into cloud storage as a GIF, as a JPEG. And then we set up Knative so that whenever there's a file that's saved into cloud storage, it will send a notification to another service called Notifier. And this Notifier service, whenever it sees a new chart, it will use SendGrid, which is another online service, to send emails, right? So it will send an email to me, and it will say, okay, there's this new chart with new data, right? So at the end of the day, at 4 p.m., I will get an email that will say, okay, this is the new cases for today, and this is the chart for the day, and I'll look at the COVID cases. So you can see that this is totally event-driven. It's done. It's kicked off by Cloud Scheduler, but all the services they're loosely coupled. They don't really know about each other. They just get triggered by events. So Chart Creator will get this custom query completed event. The notifier will only get events from cloud storage. And Knative kind of enables all of this with the things that it provides, right? So let's actually take a look at this and see if we can make it work. So what I'm going to do is I'm going to go to Eventing, and then Processing Pipelines and BigQuery. And by the way, this is all on GitHub, so I will share the link with you if you want to run it yourself. First, let's create our scheduler source, and let me actually show you what these look like. I won't get into the code, unfortunately, because we don't have that much time, but just to show you the configuration a little bit. So in this scheduler source, I'm using the Google Cloud's Cloud Scheduler source, and I'm saying that every day at 4 p.m., I'm going to send a message to the sink. In this case, it's the broker. And in the message, I'm just going to say United Kingdom. So it will send a message with United Kingdom in it, and then broker will send that message to the connected services. And I also have a storage source. This is for the charts. Once the charts are saved in this bucket that I defined, I also want to send a message to the broker, right? So these are the two sources that I want to create. So let's actually do that first. Scheduler source UK. And then let's create the storage source charts. And then I have these three services: Chart Creator, Notifier, and Query Runner. Just to look at the configuration of these, the service is just a plain Knative service that points to a Docker image. But the trigger, you can see the trigger for Query Runner, for example. Query Runner only looks at the filter. It only filters messages, and it only looks at the messages from scheduler. So it won't look at anything else. And once we see a scheduler message, we'll send it to the Query Runner. And then if you look at the notifier, for example, it filters with storage events. And if you look at the chart creator, it filters with this custom cloud event, query completed, right? So let's create those as well. So I will go to query runner first, and then say Kubernetes apply, create the service, and create the trigger. And then let's go to chart creator and create those as well. And then finally, notifier, create those as well. Now, if we look at the Knative services, you see that we have three services running. If we look at the triggers, we have three triggers that are not ready yet, but they will be ready soon. And if you look at the pods, you should see some pods that are being created as well. Now, to trigger this pipeline, I can wait till 4 p.m. till tomorrow, but I can also manually trigger the scheduling job. So if I do gcloud scheduler jobs list, I should see a job that's scheduled to run at 4 p.m. That's already set up for me. And I can trigger this manually. So I just do scheduler jobs run, and then I will just pass in this ID. So this triggers the pipeline manually. And then if we actually do get pods, you will see that the pods are running. So first, let's look at the query runner logs, for example. If I do kubectl logs, and then we want to look at the user logs, user container logs, you can see that the query runner, it received a cloud event. So this is the cloud event it received from the scheduler. Then it's executing the query, and then it's replying back with this custom cloud event, right? So it's basically received it, run the query, and reply with that. And if we look at another pod, for example, let's say let's look at the we look at the chart creators, see if it created the charts. So you can see that the chart creator, it received the query completed message, then it looked at the table, and then it created a chart and it saved it to the bucket. So it looks like it's working. And if I actually check my personal email, so let me do that here. Yes, let me show you this. Let me pull this to this screen. 1 second. So this is my personal email, and I don't know if you can see this, but we got a new email just now, 1 minute ago. It says a new chart from BigQuery pipeline, and if you open the chart, it says there's a chart for you, and this is the COVID cases in the United Kingdom. As you can see, we started well in March, then it's picked up in May, then it slowed down over the summer, and now it's picking up again, unfortunately, as in every other place. But hopefully this gives you an idea on the type of things that you can build with Knative. I want to just quickly go back to my presentation so I can share the links with you. As I mentioned, the slides are already on my speaker deck. This GitHub repo that I have, Knative tutorial, has many stories on Knative in case you're interested. And as I mentioned, if you're on Google Cloud, you probably want to run Cloud Run instead of Knative because it's an easier way to run Knative. I also have a tutorial for that as well. Feel free to check it out. I will just stop here and ask Ron if we have time for questions, and if there are any questions, I'll be happy to answer. If not, enjoy the rest of the conference. Thanks for listening.